Hello all, it is Monday actually because we are no longer doing these notes on Friday. It is Monday, we are going to do our notes on precession and nutation. They are doodle notes, they look like, actually I have a picture on the screen for you. First things first, we're going to turn to our bell ringers. We've done our vocab, we did that last time. We did this bell ringer, here's your next bell ringer. Try and label, if you've ever seen this diagram before. If you've not, you can just put a question mark. We'll go over the answers in a second. Try and label the three different parts of this diagram. Remember to pause the video. Okay, let's go over it. So the very first one is precession. So precession is the wobble in the Earth's rotational axis. And the second one is the nutation, which is actually the change in the angle of the tilt of the Earth over time. And number three we know is rotation. So as the Earth rotates around and around, it actually, the way the axis point actually wobbles as it goes around. And then the nutation is the change in the angle of the Earth. So if you didn't know, last time we learned that the angle of the Earth is 23.5 degrees tilted, the axis, so it's not straight up and down, it is tilted. So we learned that it's 23.5 degrees, but that's actually not every single time. That's an average, so sometimes it might be a little bit higher, like 24.5 degrees, and sometimes it might be a little bit lower, like 22 degrees, right? Very awesome. Something we're going to study today is a little bit more in depth about the Earth's movement. So we've already done these Kepler law doodle notes. We're going to go on. I did want to highlight for a little bit some female scientists. So Cecilia Payne-Gaposchkin, she is the scientist that discovered that the sun is made of hydrogen and helium gas. Remember we said that in nuclear fission, which happens on the sun, that's how it creates the energy that we use here to power photosynthesis, to power solar panels, to warm our earth and our water, right? So she discovered that it is made of hydrogen atoms and helium gas. So those two hydrogen atoms fuse together to create helium, and then that's what it is. They also release a ton of energy when they fuse together. Okay, motion of the Earth. So this is where you're going in your doodle notes. This is what page I would like you to go to. We're going to start with precession, okay? Starting at the top. Precession. So precession is the wobble in the Earth's rotational axis. It doesn't happen very often. We're actually going to find out. Sorry. Let's please label this diagram. The Earth is rotating around its axis. Remember we said when it moves around the sun, we call that revolution. We're just talking about rotation today. When the Earth spins on its axis. The line of precession is actually the wobble as it goes around in a circle. Precession, like I said, doesn't happen very often. One cycle, one wobble takes 26,000 years, right? So this will never happen in my lifetime or your lifetime. Precession is caused by the force of the sideways pull on the sun and the moon on the Earth's equator. One of the results of precession. Sorry, quick, what causes precession? Remember, precession is caused by the force of the sideways force pull from the moon and the sun on the Earth's equator. The result of precession, so if precession were to happen, or when it does in 26,000 years, our current star right now is Polaris. Our Earth is pointed straight at Polaris, right? And whenever we rotate around, we have a rotation of different stars, if you didn't know, different constellations. But the one thing that is always the same is that the North Star is always right there. The North Star never moves. Everything else rotates around it. We are halfway through the cycle. So in 12,000 years, our new North Star will be Vega. So if this is where my Earth's axis is pointing right now, my hand where the Earth and my finger where the axis, we are halfway through, so we are going to wobble until our North Star is Vega. Vega is a constellation or a star in the constellation. I feel like it's Aquarius, but I could be wrong. So what we're going to see, if I asked you for evidence of precession in 26,000 years, you would see a change in the North Star. So right now it's Polaris. If precession were to happen, so if we lived 12,000 years from now, Vega would be our new North Star. Okay, so right now, if you can see, Polaris is right there. We're about halfway through. If we were to get all the way through, Vega would be our new North Star. Let's see. I forgot I put a picture here. Vega is right there. Sorry, in Libra. Lyra is what it is. Our new North Star is here on Ursa Minor, or the Little Dipper. All right. I asked my class this last year, but do we know what this was called? I can't remember her name, but the famous woman who led again and again trips from the non-free South, so the slave states, up into the free North states. They would follow the North Star or follow the drinking gorge, because this looks like a ladle that you would drink from. Many of my students didn't know that. All right, so precession. Right now, here's what we've got. This is what would happen. This is our present. So the northern hemisphere is tilted towards the sun at the alpha-helion. So remember we said our alpha-helion is when the Earth is furthest from the sun on its path. It is at the alpha-helion. It is going the slowest. Right now, when that happens, we are the furthest from the sun. So we experience summer when we're furthest from the sun. The northern hemisphere is tilted towards the sun at the alpha-helion, and it's tilted away from the sun at the perihelion, so it's winter. That's what would happen now if we were looking at the northern hemisphere. That's what that NH means. Remember, alpha-helion is when the sun is furthest, or is when the Earth is furthest from the sun. Perihelion is when it was closest. Okay? Here's what would happen if we switched. So if this was 12,000 years later, or precession had fully finished its cycle, the northern hemisphere would be tilted away from the sun at the alpha-helion. Therefore, it would be winter in July and summer in January. Just a reminder that perihelion is when the planet is closest to the sun, and and when the planet is closest to the sun, it moves the fastest. So our result of precession is that the seasons flipped. Winter in the northern hemisphere would be June, July, and August, and winter would also be colder. And summer in the northern hemisphere would be December, January, and February, and summer would also be warmer. Okay, a little bit of review for you. What is the tilt of the Earth right now? 23.5 degrees. But did you know that the tilt can vary between 22.1 degrees and 24.5 degrees? What phenomenon causes the tilt, or what phenomenon does the tilt of the Earth create? We're going to learn this in a couple more lectures, but it actually creates the seasons. Here we're defining nutation, so at the top of the very bottom section. So nutation is a change in the angle of the tilt of the Earth's axis. Remember, I said it's not consistent, right? We learn it as 23.5 degrees, but that's not what it is all the time. So, and this is a typo right here. It should say 22.1 degrees. 22.1 degrees. So if the temperature of the tilt is decreased, we see a less of a difference between temperatures, right? So less of a degree difference when we're talking about our different seasons. When the tilt is increased, we see more of a difference in between our temperatures of the seasons, right? So we would have a colder winter and a warmer summer, and we would have a colder winter, warmer summer. Here we would have more mild winters and more mild summers. Okay? I hope this helped. I'll try to put up some additional videos for you to help you understand nutation and precession a little bit more. This is something that you will be tested over on your EOG, so please, please, please make sure you understand this. We'll review them in class, hopefully, and if you are tuning in electronically, make sure you're reviewing these on your own. Have a great day, guys.